Hello everyone, today let's solve the problem number 152, maximum product subarray. So what the question states here, just give me a second here. What the question states here, we are given an integer array nums, you can clearly see here, we are given an integer array nums and we need to find the contiguous subarray that has the largest product. So we have to find the contiguous subarray. So within this elements contiguous subarray we have to find, and we have to return the largest we have to find the contiguous subarray that has the largest product. So this I forgot. So which has the largest product we need to find, and we have to return that product. So what we need to find here, we need to find the contiguous subarray that has the largest product, right? So that's what we need to find here. So let's come to example 1 here. So this is the 2 and 3 first. This is the this one largest product, right? This is the contiguous subarray that holds the largest product here, nothing but 2 comma 3. Here we will be multiplying 2 into 3, that is nothing but 6 here in this case. So that's what they have given in the question. Second example, let's come to the second example. Nums of -2, 0 and -1 we have. So here in this case what they have given, result cannot be 2 here, because -2 into -1 we can consider, but -2 and -1 is not a subarray here in this case. So we have to either go continuously, contiguous subarray they have given, right? We have to find the contiguous subarray that has the largest product, means continual or continuous subarray or contiguous subarray, means either we can consider 2 comma 3, then we can consider 3 comma 2, then we can 3 comma -2 here, then we can consider -2 comma 4 here in this case. So in this case 3 comma -2 will be -6, -2 comma 4 will be -8, and 2 comma 3 will be 6 in this case. So we are considering 2 comma 3 here in this case for the first one, right? So same goes with second one. -2 comma 0 we can consider because it is continuous. -2 comma 0 will be 0. Anything multiplied by 0 will be 0, and 0 into -1 will be 0 as well. So anyhow, whatever we consider here, the output will be 0. So the output we have got is 0 here. In this case it is 6. I hope the question is completely clear here. So we have seen how we got 6 and we have seen how we got 0. So let's try to understand how can we implement this one in the form of code. Let's discuss the approach first, followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, let's discuss the approach. So let's discuss the approach step by step. First thing that we have to keep in mind here is we will be going with the dynamic programming, right? So we will be making use of the cadence variant or cadence algorithm along with the dynamic programming. Just keep this in mind. Dynamic programming, nothing but cadence variant or cadence algorithm. So here in this case, I have just considered the same first example that they have given in the question, 2, 3, -2 and 4, and output has to be 6. Let's see. Let's come to the step 1 here. So we will be going with the dynamic programming or the cadence variant, as I have said here. So we will be making use of two variables over here. One is maximum product and one is another one is minimum product. In this case, this is maximum product, this is minimum product here. So to track the highest and lowest product at each index, we'll be making use of maximum product and minimum product. Again, I'm telling, just keep this in mind. To track highest and lowest product at each index, at each particular index, we have to track highest and lowest product. So that is the reason we'll be making use of max p and minimum p, nothing but maximum product and minimum product. So let's see the iterations. Initialization, let's go with the initialization here. When I say initialization, first number here is 2. So the current number we have considered here will be 2. So max p will be 2, min p will be 2, result will be 2. In this case, we will be going with this formula, but this is initialization part. So max p equals max of n comma n into max p comma n into min p. So cadence algorithm will be making use of, right? So this is for the min p and this is for the result. So in this case, let's move on with the iteration 1. So this is for the initialization. We went with initial number 2. Max p now we have is p 2, and max p min p we have 2, result also we have 2 here, right? So let's go with the iteration 1 here. Nothing but we will be processing 3. When I say we will be processing 3, we will be considering the second number, so we will be processing 3 here, right? Let's come to the iteration 1 here. Current number we have considered here is 3. Max p, we will go with this formula, max of n, nothing but here in this case max of n is nothing but 3 here, n into max p we have here is 2, min p is also 2, result is also 2 from the previous step. So n into max p is nothing but here 3 into 2, or we can just write here 2 into 3. So this will be 2 into 3, and n into min p. Min p is also 2 here. So 2 into 3 again we can give here. So this will be 3 comma 6 comma 6. So maximum will be out of 3, 6 and 6, maximum we can consider 6, right? So again here we will come min of here again we'll go with this formula n into temp. Here in this case same thing, 3 comma 2 into 3 comma 2 into 3 here in this case. So it will be 3, 6 and 6. The minimum out of 3, 6 and 6 we will be considering here 3, right? So the result is result comma max p in this case. So the result will be 6 in this case, right? So result will be 2 comma 6 in this case. Previously it was 2 here in this case. It will be if I calculate min, right? We are going with max, sorry, result, this one result uh, equals max of result comma max p. Previous result was this one 2. If you can see here, previous result was 2, and max p, now we got max p is 6, out of maximum here is 6. So the result here will be 6, right? So I hope this is completely clear. This is 6. So let me come to the second iteration. Again we will go with the same formula here. So this will be max of we are going with the current number -2. We are processing -2, so we will consider -2 here. So this will be previously we got result 6, right? This will be 6 into or 6 into -2, and again this will be 3 into -2. So this will be 6 into 2 -12 and -6 and -2, out of which is the maximum here -2. So we are not considering the bigger number when it comes to negatives, right? So -2 here, -12 here, and -6 here. We are going with the max, means this one lesser negative number, -2 here in this case. Minimum p n of temp, this one. Again same formula we'll be going with. This will be min of uh, -2 here, 6 into -2. Again this will be 3 into -2. Again here minimum will be -12. So out of this one minimum is -12, because we are dealing with the negatives, right? Here this will be -12, -2 and -12 we got. So result will be max of previous result, max of result comma max p. So previous result we got here was 6. So 6 comma max p is -2. So maximum will be 6 in this case. Maximum of 6 and -2 we got here 6. So result will be 6 in this case. Let's come to the third iteration. Current number we are considering here as 4. In this case we are processing 4. So here this one. Let me come here. -2 we have already considered in the previous step. So we will be going with the 4, the final number, right? So it will be the final iteration here. So this will be, let's come to the step 3 here. Step 4 here, sorry, max p, same thing, same formula we will be going with. So current number we have considered 4, it will be max of 4 comma -2 into 4 here, because -2 is the last previous result, into 4 n into max p, right? Here max p will be going with 4 here, because we are considering the current number 4. Same thing, this will be -12 into 4 in this case, -12 into 4. right? So I hope this is clear. So this will be min of same thing, 4 comma minus 2 into 4 here, and again minus 12 into 4 here. This is fine. So this will be 4 here in this case, because we get 4 into 4 comma minus 8 comma minus 48, which will be 4 will be maximum. So here minimum we will be consider minus 48 here, minus 48, right? Result will be max of 6 comma 4 here. This will be max of 6 comma 4, and here this will be in this case 6 comma 4, maximum will be 6, right? So maximum will be 6 in this case, right? So 6 comma 4 out of maximum will be 6 in this case, and the final iteration we got the 6 as output, so we will return this one as output here. So this one, so let me consider here, yeah, this one we will be considering as output, final answer. So just give me a second here. So final output here will be 6 in this case. I hope this is clear. So what is the output that we need to get here is, output we need to get here is 6 as well. So the approach works absolutely correct here, right? So we went with dynamic programming with cadence variant or cadence algorithm, right? The final output that we got here is 6, which works absolutely correct in this case. The approach works absolutely correct. So let's quickly discuss the edge cases one by one here. First one is for all the first one is for the case all positive numbers 1 2 3 4. You can just visualize in the same way that I had showed for the example 1 in the approach. So here the output will be 24. Why it is 24 here? Because product keeps on increasing here in this way, right? So this will be 24. In this case, let's go with all negative numbers for the second case. So this will be, output will be 24 as well, because product negative numbers, multiplication of the negative numbers will lead to the positive number in this case. So the minus 24 will be the product. So all negative numbers, this is nothing but odd count we are going with. So all negative numbers will be going with nothing but odd count, minus 1, minus 2, minus 3. This will be, in this case, it will be 6. The largest subarray product will be here, minus 1 into minus 2 into minus 3, nothing but 6 in this case, right? So let's go with the fourth edge case here, contains 0. So contains 0 means here in this case 0 comma 2 comma minus 1 comma minus 3 here I have considered. Output will be 3, because 0 resets the product calculations. You can just visualize in the same way that I had done here. 0 into 2, 2 into minus 1 will be minus 2, and minus 1 into 3 will be 3, out of which 3 is the maximum. So this one product, so maximum product right here, this one we have to consider. Single element we have, output will be 5 itself in this case, right? So because single element is always the product, we'll be considering 5 as output here. So these 5 edge cases we need to consider. So the first edge case was for the all positive numbers, second edge case was for all negative numbers, third edge case was for all negative numbers, nothing but third edge case was for this one, I think, all the negative numbers but odd count. So second edge case was for even count here, all negative numbers with even count. So this one contains 0, and the fifth one is for single element. I hope all the edge cases are clear, right? So now let's start writing the code. So let's start writing the code. We already know that we'll be making use of the max product, minimum product, and the result. Let's initialize that one to the, let me initialize max product to first number, nothing but nums of 0, first index here. So min peak or the min product, let me initialize this one to the first step. If you remember in the initialization, so just give me a second here. Oh, I missed n here. In the initialization part, we were considering the first index, the element present in the first index, right? So that's what we are initializing here. Maximum product to this one first number, minimum product to the first index again, and result to the first index as well. So this we know, nums of 0. This is fine. So the second step was we have to iterate through the each element, right? So I'll just give here, let I equals 1, I less than length of the nums, and let's increment the I here. This is fine. I hope this is fine. So initially what we have to do, we have to store the current number and temp, right? We have to store the current number and temporary maximum product before updating. So here I'll just give n equals iterated value of the nums as well as temp equals maximum product. This is fine. So I'll just delete this one. So next thing here is we have to update the maximum product. When I say we have to update the maximum product, we have to take maximum of current sum, product with previous maximum product, and product with the previous minimum product. So this one, if I rather than saying this one in the theory, so I'll just write this one directly. So we have already made use of the formula, right? So again I'm telling, we have to update maximum product, we have to update the minimum product, and we have to update the result every time. That we saw in the approach, step by step, step 1 to step 4 for the example 1. The same thing, the same formula will be giving here. Let's update maximum, max p, min p, and result. So for max p, I'll just give here math dot max of here this one n comma n into max p comma n into min p. This is fine. This is min p here, math dot min of n comma n into temp comma n into n into min p. This is fine. And finally the result is max of result comma max p. So here this will be result will be max of result comma max p. This is fine. So what we did here, we have updated max p, we have updated min p, and we have to update result. So we are updating max p, we are updating minimum p, and we are updating the result, right? So this we saw this one during the approach as well. Nothing ambiguous here, right? So let's move to the final step. We have to return the final result. The last step we returned the final result, if you remember. So I'll just give here, in this case we are going with the res variable, right? Result variable. So I'll just return result here. So let me format this one once and let me hit the run button. I hope this works. Result equals max is not defined. Where I have made use of the max? Oh, here this has to be math.max, right? So yeah, this one we are articulating this one in the form of code, right? I forgot here. This is fine. So now you can clearly see the sample test cases are getting passed. So let me hit the submit button very clearly. So you can clearly see here all the test cases are getting passed. So the code works absolutely correct in this case, right? So the approach that we went with here is cadence algorithm or dynamic programming with this one, cadence variant. So the time complexity here would be big O of n. Let me give here the time complexity would be big O of n. Why the time complexity here is big O of n? Because we are making use of the single pass over the array. You can clearly see single for loop, single pass for the array, right? So next, what would be the space complexity here? The overall space complexity would be big O of 1. Why? Because we are making use of only few variables here, max p, min p, and the result. So we are making use of only a few extra variables here. So the overall space complexity would be big O of 1 here. I hope the solution is completely clear, right? So the time complexity would be big O of n and the space complexity would be big O of 1 for the code that we have written, right? So I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.